All right, so today we're going to talk all about triangles. So we start off classifying these bad boys. We can classify them by their angles and by their sides. So it's a little refresher. We have an acute triangle if all of the angles are acute. Remember, acute angles are between 0 and 90. So anything from 0 to 90 degrees. A right triangle has one right angle in it. So remember, right angle is 90 degrees. A obtuse triangle has an obtuse angle in it. Remember, obtuse is between 90 and 180 degrees. And then an equiangular triangle has all congruent angles. So remember, congruence is the same, and we know that these are actually also 60 degrees. Scalene, if we're looking at sides now, scalene has no congruent sides. Isosceles has two congruent sides. And then equilateral has all congruent sides. So if we look at these two triangles, if I look at my first one, let's start with its sides, 3.1, 4.1, and 2.6, all different. So this is a scalene triangle if we're talking about sides. And then for angles, I have a 40-degree angle, a 50-degree angle, and then this 90-degree angle. Since I have that right angle, this is a right triangle. So this is a right scalene triangle. And if I look at the second one, I have 2.5, 2.5, and 4.5 are my side lengths. Well, we got two congruent sides, so this is isosceles. And then if I take a look at the angle measures, 25, 130, and 25, we have that obtuse angle, so this is an obtuse triangle. So this is an obtuse isosceles triangle. So that's classifying. Let's start with the triangle sum theorem. So, triangle sum theorem says we know all interior angles of a triangle add to 180 degrees. So, if we want to find this missing angle measure here, well, we have this 44 and 43 degree angle. Whatever this is, it's got to get us up to 180. So, that's always how you set up your equation when you have the interior angles of a triangle. So, when I combine this, I get that this is 87 plus this is 180. Subtract that 87 over, I get that this is equal to 93. So this is a 93 degree angle. Boom. And then if I'm looking at this next one, now again, algebra, don't freak out. Geometry doesn't change. Add them all up, set them equal to 180. So this x plus 52 plus x plus 52 plus, don't forget, 90 degrees plus 90 is equal to 180. All right, algebra. Combine my like terms. Boom, 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 boom. X plus x, 2x. 52 plus 52, 104, plus 90, 194 is equal to 180. 2x plus 194 equals 180. Subtract that 194 over, so I get 2x equals negative 14. Divide by 2, so my x here is negative 7. So if that question said what is x equal, you're done. But let's say it said, what is the measure of angle A? Then what we need to do again, we need to take that negative 7 and plug it into angle A. So angle A is up here. So I would do this as negative 7 plus 52, and that is 45. So this would be a 45 degree angle. All right, on to the next theorem. So we have the exterior angle theorem. This one can get a little confusing, but again, think it's always just the two non-adjacent interior angles add to my exterior angle. So I have that this is 88 plus whatever this angle is here has to get me to 148 degrees. So if I subtract that 88 over, I get that this is a 60 degree angle. Boom. 60 degree angle, and we are done. If I'm looking at this second one, what we do again, we add the two non-adjacent interior angles and we set it equal to my exterior angle. So this would be 74 plus 5x minus 10 is equal to 10x plus 14. That's the setup, the rest is the algebra. So combine my like terms on the first side. So I have 5x plus 64 is equal to 10x plus 14. All right, x's to one side, constants to the other side. So I would subtract my 5x. So 64 is equal to 5x plus 14. Subtract that 14 over, so we get that 50 is equal to 5x. Then last step, divide by 5. My x here is 10. But the question asks, what is the measure of angle QBC? If I'm looking at QBC, Q to B to C, I am talking about this angle right here. So we need to take this x, plug it into 10x plus 14. So 10 times 10 plus 14. 10 times 10 is 100, plus 14 is 114. So this is a 114 degree angle. Okay. Common mistake with the exterior angle theorem is people think when you have these variables, again, the trap, you have to add the two x terms together. Not always the case. Not always the case, okay? So then, let's move on to equilateral and isosceles triangles. So remember, the property that we know about equilateral triangles is that they are also equiangular. So if all the sides are congruent, then I know that all of the angles are also congruent. And more specifically, we know that all angles measure 60 degrees. So whenever I have an equilateral triangle, all of them again 60 degrees. The sides might be different, but we know that the angles are always 60. Okay? And then when we work with our isosceles triangles, we know that angles opposite the congruent sides are also congruent and vice versa. So let's say I have this triangle, and I know that these sides are congruent. What we know then is, since these sides are congruent, we know that the angles opposite them are also congruent. So that angle and that angle are congruent. So we have that. And then vice versa. So let's say instead, this is the information I have. Let's say I have that these angles are congruent. Since I know that these two angles are congruent to each other, I know that the sides opposite them are also congruent. So boom, boom. Okay? Vice versa. So let's work through these 4 examples. So first one. I'm given that this angle here is 40 degrees. And so I want to know, what's this angle? Well, this 40 degree angle is opposite this side, which happens to be congruent to that side. So we know that the angles are congruent. This is a 40 degree angle, boom. Next one. I have an equilateral triangle. And remember, equilateral means that we also have equiangular. So 2 ways to do this. We know that all of these are 4x. So I could do 4x plus 4x plus 4x is equal to 180. Do the math. 12x is equal to 180. So then we get that x equals 15. Okay, great. Another way that we could do it is, let's say instead, I didn't want to do all of that. Well, didn't have to erase that. 4x, 4x. We can work with the fact that equiangular triangles' interior angle measures are always 60 degrees. So we could just do 4x is equal to 60 if we work with that fact. Divide by my 4, x is still 15. Get you the same exact answer, both correct ways to do it. Next one, we have an equiangular triangle. What does that mean? Correct, all the sides are congruent. So that means we know that 4x plus 1 is equal to 5. So if I subtract that 1 over, 4x is equal to 4. So my x here is 1. There we go. Last one. So let's say I have this 30 degree angle. This 30 degree angle is opposite this side. Oh, congruent to that side. So we know that these 2 angles are congruent. Do not fall for the trap and think that that angle up top, that vertex angle, is also 30. This angle is my 30 degree angle. So we need to work with the fact now that we know that all triangles' interior angles add to 180 degrees. So we would need to do 30 plus whatever the angle is, gets us to 180. 60 plus what this is 180. So we get that this is 120 degrees. Not drawn to scale, but there it is.